Hello. In this video, I want to go over what is the most important video you'll ever see as a beginner game developer or any type of developer. This isn't just for game development, but we're going to specifically be talking about this in the scope of game development, just because there's a couple of things that you might not have to do in other types of development, but you can do. The thing I'm talking about is source control. Or version control. Version control is a way to save your projects into multiple different versions so you can work on them, different versions of your project if you want to test things out, or if you just want to keep stuff separated until you're sure that it works, which is like the best way to go about working on your project, right? And version control is also the way that you collaborate with other people online. So if you're working with somebody all the way on the other side of the world, this is how you go about doing it. I'm going to have links to everything that you need to download below. First thing to do is to make a GitHub account, and GitHub is sort of like the place where you can store all these files, and this is how other people can download your project in order to work on it with you. And then we also have GitHub Desktop, which is going to be the thing that we're going to be using in order to actually work with Git. Then we have Get, and this is the actual program that you need to download in order to use Get. So you have to download this before you do anything else. And then Get LFS, which is basically a program that converts big files into smaller files. And then when you use them, it converts them back into the big files. So this is a way to work with big files. So these are all the programs that we have to download, these three: Get LFS, Get Large File Storage, and GitHub Desktop, which is going to be the thing that we're going to be using. So in order to make a new repository, a Get repository, a project, the first thing that we want to do is make a new repository. And then here, you just type in your name, the name of your project. So in my case, I want it to be Veras, and then just create a collection, give it a description, a collection of, and then you can choose if you want your repository to be public or private. This is up to you if you want to develop out in the open, if you want anybody to download your project and work on it or build off of it or do anything with it. You can set it to public. If you're trying to make something private, like if you're trying to make a game, for example, set it to private, and then nobody can access this unless you give them permission to access it. And then you have a README, and this README is basically just a file that GitHub can use. All the README does is it just tells anybody who goes onto your repository, tells them how to use your project or how to install your project or anything you want. And this is not auto-generated. You actually have to write this out. So in my case, I would write something like, hey, install Unity, this version of Unity, install it, and then everything should be working fine. Then your get ignore. This is really important. Get ignores are just files that tell Get to ignore like specific files and folders. In our case, I'm going to be making a Unity project. So all I'm going to type in is Unity and then just click on that. We don't want Get to track, which keeps your repositories smaller. So you can do more stuff without filling up all the space. I think on GitHub, they have like a 1 GB limit, and sounds like really small if you're working on games. Like, how am I going to fit 1 GB into GitHub if I'm making a game? Well, if you use Get LFS and you use a get ignore and you don't track things that you don't need to track, this massively reduces the files in your game. Your license is going to be how you want other people to use your code. Usually if you're making a private repository, you don't want anybody else to use your code, so you don't really need a license. But if you are interested in working on something in the public, this is how you would legally cover yourself if somebody tries to steal your code or use it in a way that you don't want to use it. Okay, probably the most popular license is going to be the MIT license, and you can read through it yourself, the MIT license. For my case, don't want anybody else to use my code, so I'm just going to create the repository. Now we have our get ignore, and we have a README that we can add because I didn't add it yet. Okay, now in order to actually download these files, or in order to have this repository on our actual computer, because we just made it online, it doesn't exist on our computer yet, we're going to go over here. Make sure that you have GitHub Desktop downloaded. We're going to click on download or open with GitHub Desktop. Going to click on that, and then we're going to click on clone. And then now we should have this Vedas demo disk. And then if we right click on it and then go to show in Explorer, see that now, yeah, we do have this folder called Vedas demo disk. In order to make this project, I would go to here, new project, and then type in the project name, Vedas demo disk. Now you'll see we'll get this error saying the project already exists with this, but we can actually go inside of here, select this, and this is, I haven't found a workaround for this that is easier. There is a way you can do this just using get bash, but it's a little more complicated. This is a little bit of a hassle, but okay, I'll just show you. So I'm going to go ahead and make the project, and it's going to take a little while for me to actually, for Unity to actually build out the project. So we'll cut ahead and continue once it's done. So now that we have this project created, Unity has created this project. I'm just going to remove that README. You'll see if we open up our GitHub desktop, you'll see that we have a ton of files in here, almost 30,000 files. The reason why is because if we go back into our Vedas demo disk, you'll see that we have our get and our get ignore above this, and then we have our actual project here. Problem is that we don't want the project here, we want the project here. And the reason why it made it here and we weren't able to make it under the same directory is because we can't make an empty get project. We would have to make our get project here, but the way that I showed you how to do it is just easier if you're a beginner. You know, if you know how to use get bash or if you know how to use the terminal, there's either easier ways to do it. This way is just easier if you're a beginner. And, you know, I think, but in the future, you should definitely learn how to use a terminal once you get more comfortable with just the process. But for now, I think it's way, way more important for you to just learn the process, you know. Okay, so in order to fix this, we're actually going to close down Unity because it's not going to let us adjust these files until we actually close it down. And we're going to get all of our files, and then we're going to see this number here. I think it's cool to see this number shrink down massively. We're going to 27,705. We're going to cut this, then we're going to paste this up here. And now we no longer need this demo disk folder because everything exists up here now. If we click back onto GitHub desktop, you'll see it went from almost 30,000 files to 46 files. And the reason why it did that was because we have our get ignore over here. And the get ignore is just like a file that tells our get, ignore these files. This is how that looks like, is in our get ignore. And if you don't see this get ignore, or if you don't see this get, make sure that you go to view and then click on view hidden items and also view file name extensions. Okay, let me step back. So the way that get works in GitHub is that get expects you to make some changes, and then you're going to say, hey, these are the changes that I made, and then you're going to upload those changes. So this is a 3-step process. GitHub desktop does one of the processes for you automatically, and that process is adding the files that you changed into your collection of changes. And it does that automatically just by doing this. So that's all it's doing right here is this checkbox. It's saying like, hey, these are the files that I've changed. Then the commit is going to be, you can see over here, it says commit to main. This commit is basically saying, hey, these are the files that I changed during this instance. Now for this first initial commit, these are just the beginning files, you know, so there's nothing that we really did over here. So I'm going to type in initial commit, just like that. And then I'm going to type in a description of what are in these files. Say, these are the files that were auto-generated by Unity for their universal render pipeline template. And then we're going to commit to main. And now once you commit to main, you'll say 0 files change. This means that all of these files change are now tracked in GitHub. GitHub desktop is waiting for another set of changes in order for you to commit, in order to upload them. Now, this is really important. All of these changes and files only exist on my computer. So if we look over here and we refresh this page, it looks exactly the same. We added an entire new project, but we don't see it because they only exist on our computer right now. In order to push it over to GitHub, all we have to do is click push origin, just like that. Now, if we check over here and we refresh, you'll see now it has a bunch of folders and stuff, and it says it committed 1 minute ago. So we actually have all of our changes online. And then if we go back to Unity, we'll try to open this project, and I believe it'll say project failed to open. And the reason why is because we moved our project from this location. So we're going to just remove it from the list, remove project, and then we're going to add a project from disk, and then we're going to click on that location. And now when we open it up, it should actually open up this time. So now we have our project open. We have GitHub desktop over here. I'm going to do something really quick just to show you that the process. Okay, I'm going to make a quick 3D plane. Cool. So now we have this 3D terrain. Let's go ahead and add in a capsule. Now we have this capsule. We have this terrain over here. We are going to go into our GitHub, and you'll see that GitHub desktop automatically noticed that we made new changes, and it automatically added it to this commit. Now the commit doesn't exist yet because we haven't given it a name, and we haven't given it a description, and we haven't committed it. So it just doesn't exist, but this is called staging. This is the process of the get process where nothing has happened yet, but you're preparing for something to happen. And like I said, GitHub desktop does this automatically. It just checks like, hey, have any changes been made? Yes, let's go ahead and stage these changes. And then whenever we make a commit, we know what files have changed, and we know what to, like, it tracks like the files that have changed for us automatically. Okay, so I just added a couple things just to show you how to add a commit and what that process looks like once you've done the initial commit. I am just creating an example commit, but whenever you name a commit, you want to do it in the second person. It's just like a naming convention thing, but I'm going to name the commit, the summary, say create example commit changes. And then here, I'm going to be more descriptive about what I did, as I added in a terrain and a 3D capsule that will act as a player to show a YouTube video how to create a commit. And then I will commit to main. And again, this process of committing to main just saves these changes onto our personal computer. And if we look on GitHub desktop, we so far do not see these changes anywhere. Once we put push commit or push to origin, now we actually have changes on our GitHub. When we refresh, we'll see now we just made changes right now. And now if we click over here to 3 commits, you'll see that we have these 2 initial commits, initial commit. I probably should have not named it that. And then create example commit. This is cool. We have all our changes. We're able to upload something onto GitHub, but our problem right now is that if we mess something up right now, it's going to mess up all of our files. But if we go over here, we can go back to a previous commit, but we still lose a lot of that work because we did everything on the same version of the project. So in order to essentially make an entirely new version of the project that we can mess with and do whatever we want with, we have to make a new branch. Currently, we are just working on the main branch. And if you look right here, it says current branch main. And if we click on it, you'll notice we can actually make a new branch. So let's say, for example, that I want to work on the main menu. So we can type in main menu, and then we're going to create a new branch. And then, like I said, we just made a new branch, but this branch only exists on our computer. It does not exist in the cloud yet. So in order to actually publish it, we have to click publish branch. And when we click that, you'll notice that we don't get any new changes. We refresh. We still have 3 commits, but if we click on this drop down where it says main, see that we have this new branch called main menu, and we can move over to it, and it says this branch is up to date with main. I'm going to make another branch, and we're going to call this branch example branch. Okay, example branch. And then whenever we make a new branch, you'll see that we have the option to base it off of the main branch or the main menu branch. And this is basically just saying like, what version of this project do we want to base this new branch off of? In my case, I just want to do the main menu or the main branch. So I'm going to do create branch, and then we're also going to publish this. And now this is example branch is going to be the branch that I use on my laptop. We are in the example branch. I want to move over to the main menu branch, and I want to start making like a main menu. So I'm going to delete this. I'm going to delete that, and I'm going to create a new UI. Okay. Now you can see that we added a ton of changes onto this main menu branch. And in order to make those changes, we can say, hey, added, or we're going to say, what we did. So we added a basic main menu. So I'm going to type in add base menu. Naming convention is second person, like you're telling somebody to do something. Said I added in a panel with, and we're going to commit this to the main menu. So we're seeing right now, it says commit to main menu, and then we're going to push origin. And now if we go back to GitHub desktop and we go to our main branch, you'll see that we don't see this commit. And the reason why we don't see this commit is because you see it says 10 minutes ago. The reason why we don't see this commit is because we were not on the main branch. We were on the main menu branch. Now, if we go to the main menu branch, you see this commit is one commit ahead of main. It says the last commit was now, and it was add base menu. This is the power of get and source control. The reason why this is powerful is because this main branch is perfectly fine. Like this main branch just works perfectly fine. I made a change over here, but if even in our GitHub desktop, if we click back into main and then we click back into Unity, you'll see that automatically it just changes all of our files back to what originally was on our main branch. So we go to player, like this is exactly the same way that we left it when we left off. But if we click back into our main menu, you'll notice that all of our changes that we had before are now here. Now, the reason why this is so powerful is, let's say that you want to build out this new feature, but you're not really too sure about it, but you just want to test it out, you know? You just want to test out if this new feature is a good idea, both if it works and if it's fun to use. You can just make a new branch, base it off of the main branch, and then just check if it works, you know, check if it's fun to do. And if not, you can just leave the main branch how it is. Let's say, for example, though, I say like, actually, I think this is good. I want this to be the main menu area, and I don't want this to be any different from the main branch. I want this to be the new main branch, or I want my changes that I had in this main menu branch to be on the main branch. So at this point, you would create a pull request. So you would go over here and you'll say create pull request. Now over here, I'm going to just type in the title of this pull request. Usually you would name it something like main menu setup. And say in here, in this pull request, I created the basis, and then I'm going to create this pull request. And then if I was working with somebody else, they would go ahead and look over my code, look over the changes that I made, and then decide if this was a good pull request to actually merge into the main branch. And let's say, yes, I looked through the code, I made it, so I know what I did. So I'm going to merge pull request, confirm merge, and then delete branch. So now if we go back to our code, we're going to see we have two branches now. We have the example branch and we have our main branch, and we no longer have the main menu branch. But if we see, we do have our add menu base onto here. So now all of the changes that we made onto the main menu branch now exist on the main branch. And the reason why this is cool, why this is important, is because if we go back here, we fetch origin, we switch to the main branch and fetch origin, we are going to get all of the changes that we have on the main branch. So right now, if we currently reload, so all of those changes that we made onto the main branch only exist on the cloud right now. So now this is going the other way. So we merged all of the changes from our main menu branch onto our main branch. But in our computer, we haven't made those changes yet. In our computer, the main menu branch still exists. It's still here. And if we go to it, you'll see that we still have this main menu here. Okay, we still have this. This still exists. This is still on our main menu branch. But if we go back, you'll see that it says publish branch, because this branch no longer exists on the GitHub website. So if we go back to main, you'll see that we still have the initial changes that we made with our terrain and with our player down here. Like this is still exists on our computer. Now, in order to get the changes that were on the main branch on GitHub, the website, onto our computer, we had to click pull origin. And then once we pull origin, it's going to get all those changes that were on the main menu branch and merge them into the main branch. And now just by pulling in the origin, if we click here again, it's going to ask us to reload, and then we'll see that we now have this main menu changes on our main branch, and then our main menu, it no longer exists, but it doesn't remove it from our end. So we could just delete it from here. It says, yeah, we're done with it. We don't want it anymore, but we still have the example branch. Now let's go ahead and make a new branch. And this is going to be our desktop branch. Create, we're going to publish this branch. And now if we go back, refresh, we will see we have 3 branches. We have our desktop branch and our example branch. So let's say that I am on my desktop branch, but a big part of this is that whenever we work with branches, we also want to keep the main branch always working. 100% of the time, the main branch should always be functional and should never have any bugs. The main branch is our source of truth. If ever something happens where we break something or we do something, it should always happen on a different branch other than the main branch. The main branch should always be clean. And when you do that, you're never going to lose a significant amount of work because your main branch is always going to be the place that is clean, that is free, that is no bugs, This is insanely powerful. And also really powerful is if something ever does happen to your computer, even if you keep up to date with your branches and you make sure that you're doing commits and you're pushing these commits onto your branch, if ever something happens to your computer or you lose your computer or gets stolen or gets broken or whatever happens, you don't lose your work. Your work still exists on GitHub. And when you download this project again, you can just start where you left off. And even if something doesn't happen to your computer, let's say you have a laptop, you can have your project on your laptop and your desktop, and at the same time work on it on 2 different computers, which is what I'm going to show you right now. Okay, so this is essentially what we have done so far, okay? We have created our main branch, and then before we did anything else, we created our example branch based off of the main branch at this point. Then we created our main menu branch and we made the changes from our main menu branch, and then we merged it back into the main branch. So if we take a look at this section right here, actually this entire section up here, this was just our main branch from the beginning. And then from here, this was our main branch with the main menu changes. So you can see that when we created our example branch, we were still in the red. So this example branch is currently under the red. It still bases off of the red, but we wanted to base it off of the yellow. So in order to do that, at some point after this change from red to yellow, we want to update the example branch to be based off of yellow. So instead of this being red, we want this to be yellow because this includes our changes with the main menu, right? And we haven't done this yet. So we want to do this. So how do we make it, instead of being red, how do we change it to yellow? So if we go over to our example branch, all we have to do is we go to branch and then update from main. Okay. And once we do that, once we do update from main, you'll see successfully merged main into example branch. Now, if we go to our project now, and we are on the example branch right now, and we know that because we are on example branch, you'll notice that it looks exactly the same. The reason why it looks exactly the same is because we merged main into here, into our example branch. And this is basically what we did. We just set this to here. And now our example branch is on yellow, but it's still a different branch, It's still a separated branch from our example branch. It's just updated from our main. Now, this is important. If we go back over here and we check, so I have our desktop branch, we have our example branch, you'll see example branch is 2 commits behind the main branch. That means that our example branch is not up to date with our main. But over here, if we see, it obviously is up to date with our main. So what's going on? Even though we made these changes and we received all these changes reflected on our computer, we still have to upload saying hey, by the way, we did make the changes. I am actually up to date. So this is basically what you're doing when we click push origin. You're telling GitHub, the website, I actually am up to date. So if we look at this is going to be our computer. So on GitHub, before we clicked push, GitHub thought that we were in this state because we didn't push. After we click push, GitHub now knows that this is no longer our state, that we are now in this state. So now GitHub sees that change is reflected because we pushed. And now we see, instead of being 2 commits behind, when we refresh, now it says this branch is up to date with main, saying that all those changes that were on the main branch are now on this example branch. Let's say that I'm on my desktop branch, right? This is the example example branch. I want to be on my desktop branch. Looks exactly the same. I want to make some changes. I want to add in some more stuff onto our main menu, right? Let's say I want to add in some buttons. So let's say I go to UI. So now we have 3 buttons, and we're going to type in something like add buttons. I added 3 buttons. I'm going to commit to GitHub desktop. I'm going to push origins. So we committed on our computer and we also pushed it. So now if we go back, we're going to see this hasn't changed. Our main hasn't changed. But if we go to desktop branch, we are 1 commit ahead and we are 6 commits. And the last commit that we just did was add buttons, and we could click on commits. See, yep, right there, add buttons. If we go to main, we don't see that add buttons because we only did it on the desktop branch, which is perfect, which is what we want. Let's say that we are happy with these changes. We still want to work on it a bit more before we upload it, before we ask for a pull request. But let's say we're either working with somebody else. Now we have a pull request. We say, oh, the other person I'm working with, they made a pull request. What did they do? Oh, they added a plane, so they added a rep capsule and they added a plane. Okay, cool. So I added a plane for the capsule to sit on. Okay, cool. Then we would actually go into the project. So let's go here. Let's click on example branch. We're going to reload. Yes. And we're going to take a look at this. We're going to see what did they do? They didn't do anything. They said that they added a capsule and a plane. How come we don't see it? It's because we haven't pulled from the origin. So it says last fetch 10 minutes ago. We're going to fetch origin, and then we're going to see, oh, they did make 2 commits. This 2 number means that they made 2 commits. So now we're going to pull origin, and now if we click here, we're going to reload. Oh, they actually did add in the player and the capsule and the plane. Okay, so whenever we make a change, we go to look at somebody else's branch to see what changes they made. Always make sure that you're up to date with origin. So make sure that you fetch origin, and then make sure that you pull in the commits so you can actually see the changes that they made. This looks pretty good, looks pretty standard. Now I want to go over here. I'll say, hey me, this looks great and good to go. And then we're going to comment, and we're telling the other person that's working with us like information, and we're going to merge this pull request, confirm merge, and then after it's merged, we don't need the branch anymore. We're going to delete the example branch. Now if we go here, we fetch origin, we're going to see now it says publish branch because we no longer have this branch on our server on GitHub. And when we go back to us, we're going to reload. We have our buttons, but actually we don't have the plane anymore. If we go to main, and we don't need this example branch because, we already deleted it online, so we can delete it off of our computer. We go to main, we do have that, but we don't have it on our branch. And I already showed you this before. Okay, this is a new scenario because not only do we not have what's on the main, but we do have our own changes on our branch. So if we hit update from main, and we're going to see reload, now we have our changes, and we also have the changes that were from our partner, right? That were from the other person that we're working with. We have their changes on our branch as well. And we also have our changes from our branch. And now if we click on main, you'll see this is perfectly fine. We reload. It does not have our changes that we had on our branch, right? But if we go to our branch, we have all of the changes. If we go back to our GitHub, you'll see that we have our desktop branch and we have our main branch. Our main is obviously going to be our main. We're going to be up to date with main because it is main. But our branch is actually 1 commit ahead of main, but it's also 3 commits behind. So we click on 3 commits behind. You'll see that these 3 commits are not on our branch. And again, we do see it here, but the reason why it says that we're not up to date is because we have not pushed origin yet. So once we click push origin, then now when we go back, we'll see that we are on track with main. So we are now 2 commits ahead of main. So instead of just being 1 commit ahead and 3 commits behind, we're now 2 commits ahead of main, which means that now everything that main has, we also have. Now, what I was expecting to happen was for there to throw an error because we added something onto a single scene. This is why a lot of people who work together work with multiple different scenes, is because if you work with multiple different scenes, if let's say he decided to change something, the other person decided to change something, something with the UI, and then I was working on the thing that he decided to change, there would be a thing called a conflict. And the conflict is bad because that means that somebody's work is going to get removed. It's either going to be their work or your work. Like, let's say he decided to move one of our buttons, and then I was working on that button, there would be a conflict. The way to avoid this is to separate that, like in project management, saying like, hey, I'm going to be working on this UI. Don't touch this because I'm working on it. And then you make a separate scene just for the UI. And then you have the main scene where everything is working is going to have multiple scenes loaded at the same time. This is the reason why you would work with that additive scene loading. If you're working with Unity and you're working with somebody else, is to have people working in their own scene separately. And then you combine those scenes at the end during runtime in order to have everybody's different work together at the same time. Does that make sense? So there would be an environment scene, there would be a player scene, there would be a UI scene. So then these three different aspects of the project could be worked on at the same time without any individual person worrying about their work getting overwritten. But if you're working by yourself, you could just work on one scene. Now, if we wanted to merge this stuff into the main branch, we would make another pull request. Actually, let's do one change on the main because I think some people might run into this. We'll reload. See, we don't have that anymore. We'll go to the player. Let's add something to the canvas. So maybe we will get something here. Let's get this, not this here. Okay. We're going to fetch origin. Okay, cool. Add button to canvas. Or we're just gonna, I added a button to the, and we're gonna push origin. Now we're going to desktop. Okay, I hope this causes an error. Yes, it says cannot automatically merge. Now the reason why we cannot merge after we did a pull request is because if we go back to our branch, you see we're on our desktop branch, and we go back to the main branch, and we're on the main branch, you'll see that the main branch and our branch are not up to date. So if we go to here, if we go to our desktop branch, we see that we're one commit behind, right? Because our desktop branch and our main branch are not connected, right? So this one commit behind means that we're not in sync with our main branch. And whenever we do a pull request, we always have to be in sync. See, we cannot do it because we're not in sync. We always have to be up to date. We can be ahead, but we cannot be behind from our main branch. So in order to fix that, we go to our desktop branch, and just like we did before, we update from main. We see all of a sudden, now we do have conflicts. That's because we were working on the UI. I was working on the UI. There's changes on the main branch that were also part of the UI. So now this is a problem because now we have conflicts. Somebody's code, somebody's work is going to have to get rewritten. This is what a conflict looks like. We're going to open the file and we see a bunch of stuff. Control Shift. How do we zoom in? Control plus. Yeah, we're going to go through these sections. We're going to see a bunch of stuff has happening over here. I don't know what any of this means, but this is the big headache of, you see we have some information that is like pretty easy to read, like, okay, our anchored positions are different, but there's just so much going on. So this is why it's important if you're working with somebody else, reload. You see, there's conflicts. We have merge conflicts. We can't even load up our scene because of these merge conflicts. This is why it's super important to, whenever you're working with somebody else, to separate the scenes, separate as much work as you can. You don't want to be working on the same thing, because if you do work on the same thing, the likelihood of this happening increases significantly. Last time it didn't happen because the other person was working, the other person was just me, but the other person was working in the 3D scene and I was working on the UI. This time there were two changes. There was a change on the UI and there was a change in my UI. So the fact that we're both working on the UI is the reason why this conflict happened. You should not be working in the same scene. Like, you should try to avoid that altogether. But you can see sometimes it does not cause a conflict. Sometimes it does. So you just want to avoid it as much as possible. Okay. I want to keep my changes because the person that did this on main, they did their changes, but their work wasn't as much as what I did. So I'm just going to accept the current change, which just means that I'm going to keep what I did. Incoming changes are from the main branch. Current changes are what I specifically did. Whenever we leave a branch and then we have a change, it's asking us like, do we want to bring the change or do we want to keep the change? In this case, usually you want to leave the changes. Okay. Oh, it says we can't even leave. We can't even leave because there's a conflict. We're going to go through everything and we're just going to accept our current change, which means we're keeping our work. We're ignoring the work that was on the main branch, which, you know, is that what you want to do? I don't know. Depends on the situation, you know? So we're just currently accepting all of this. And then we have one last one over here. And now if we click save, now we see that our branch, our sample scene has been resolved. We click reload. But the problem now is that the other person who added that button on the main branch no longer has that button. We no longer have that button. So if we go back over here and we look at this pull request, it's going to say to closed, open. Okay, here we go. Fetch origin. Okay, continue merge. Okay, we're going to push origin. So we're going to say, hey, we fixed all of the bugs. Now our desktop branch is 3 commits ahead of main. Okay, now if we create a pull request, we are now able to merge. But this is important, okay? If we look at main, you'll see that we still have this button down here. But if we go to our branch, you'll see that we don't have that button down there anymore. So if we say, hey, add game buttons. Okay, these are the game buttons for our different games. I removed the game, let's say it was an exit button. The exit button that was on main due to conflicts. Okay, that kind of sucks. We lost stuff because we were working on the same thing. Really important that you don't do that. Continue merge and then delete branch. Now we're going to fetch origin. See, we're going to have to publish this branch because the branch no longer exists. And then if we delete this branch, delete, then we go back to main, you'll see that we no longer have this quit button that we had at the bottom. See? So we lost work because we were working on the same thing. Super important. When you're working with somebody else, make sure that you are cognizant of what you guys are working on so you don't work on the same thing. So somebody's work doesn't get overridden. Super important. Don't do that. If you're working by yourself, that should never be a problem. But you should still work with branches because branches are the thing that is going to keep your main branch safe, so you don't ever have a main branch that is bad. Okay, so this is basically what we did in this video. We made an example branch, we made the main menu branch. After we merged the main menu, we put that into our example branch, and then after we did that, we created our desktop branch, and then we merged our example branch into our desktop branch, and then we also made a change in our main branch just by itself, which is another reason why you don't want to work directly in main. Because if you work directly in main, the likelihood of messing everybody else's work up is like significantly higher. But that is a good thing to note, that whenever you do make a new branch, you should always have this at the start of your day. You should always click update from main, and then hopefully, if you guys are doing project management correctly and not working on the same things, there should never be any conflicts. If there is, then somebody is going to have to make a tough choice of what stays and what goes. Usually, in order to decide what stays and what goes, usually decide that whatever is on main is the thing that stays and your work is gone, which sucks, but like that's why it's important to keep your project to make sure that you guys are working together properly. I've worked with a couple of different teams. There have been a few occasions where conflicts do happen. They do happen sometimes, but if you're doing this stuff correctly, it should happen very infrequently, but they still do happen. It's just an unfortunate part of just working with somebody else, Just be careful with it though, Try to avoid conflicts as much as possible. And hopefully if you're just working by yourself, you should not have any conflicts because you're working by yourself. And the branches, I hope you discovered the benefits of working with branches. And I hope that you use version control in the future, because if you don't, the chances of you just losing all of your progress, all of your files is going to be super high. You might lose an entire project with version control. The likelihood of that happening is significantly lower. It doesn't matter what kind of development you're doing, use version control, even if you're working alone. Okay. That's it. Thanks for watching. I hope I can edit this down so it's not an hour and 30 minutes. DevDog out. Ruff.